Having a formal description of a game is one thing. Being able to use that description to play the game effectively is something else entirely. In this lesson, we discuss strategies for building general game players and some of the difficulties that need to be handled. Since game descriptions are written in logic, it's obviously necessary for a game player to do some amount of automated reasoning. Now, there are two extremes here. One possibility is for the game player to process the description interpretively throughout a game. And the second possibility is for a player to use the description to devise a specialized program and then use that program to play the game. This is effectively automatic programming. In this lesson, we're going to discuss the first possibility and leave it to you to think about the second possibility on various hybrid approaches. We discuss this second approach later in the course. We begin the lesson by talking about some infrastructure that frames the problem more precisely. We then consider a couple of search-free uses of this infrastructure, namely legal players and random players. In lessons 5 through 8, we look at complete search strategies, which are appropriate for small game trees, and incomplete search strategies, which are necessary for large game trees. In lessons 9 through 12, we examine some game playing techniques based on the properties of states rather than monolithic states. And finally, in lessons 13 through 16, we show ways that game descriptions can be used to deduce general properties of games without enumerating states or properties of those states. Game player is typically implemented as a web service. As soon as it begins running, the player enters a loop, listening for messages from the game manager. Upon receipt of a message, the player calls an appropriate handler for that type of message. When the handler is finished, the player sends the return value to the game manager. Given this architecture, building a game player means writing event handlers for the different types of messages in the GGP communication protocol. There's typically one handler for each type of message: info, start, play, stop, and abort. So that means writing 5 event handlers. In order to make the implementation of these message handlers a little easier, the GGP codebase available in the course website contains definitions for the subroutines shown here. There are subroutines for computing the key components of a game. For example, find roles produces a list of roles in the game. Find inits gives a list of sentences true in the initial state. There are also some utility routines to make our job easier. For example, doesify takes a list of roles and a list of actions as argument, produces a list of sentences stating that each role specified in the roles argument executes the corresponding action specified in the actions argument. And then undoesify reverses this process. You'll see how that plays into the definitions a little later. Now, your job in building a player, as I mentioned earlier, is to use the subroutines provided to write the handlers called by the message handler. In these next 2 segments, we're going to look at a couple of simple approaches for doing this. Now, we're going to present the definitions in JavaScript. Yeah, you can use these yourself if you're building your player directly in JavaScript, or you can adjust them as appropriate to implement a Java-based version, for example. Alternatively, you can click the appropriate box in the parametric player to select from among different approaches. In this latter case, you don't need to type in any code at all, but you look at the code that we present so that you know what's going on when you make your selections.